Okay, let's start some organic chemistry practical tests of some compounds, how we can identify organic compounds. Now, the first one we are going to look at is how to identify carbon and hydrogen. So how do we identify carbon and hydrogen? The method is called combustion. And how do we do that? First, we are going to heat the organic compound in oxygen. Carbon is converted to carbon 4 oxide, which turns limewater milky, while hydrogen is converted to water, which turns anhydrous copper 2 tetraoxosulfate 6 from white to blue. This is how you test for carbon and hydrogen. So to test for nitrogen, sulfur, and halogen, you use a method called the Lassaigne test or sodium fusion test. Now, in the Lassaigne test, heat the unknown sample in excess sodium methyl. The compounds are converted to water-soluble salt, which include sodium cyanide, sodium sulfide if sulfur is present, and sodium halide, depending on the type of halogen present, which could be either chlorine, bromine, or iodine. Now, once they are converted to water-soluble salt, you dissolve it in water and filter. The filtrate is called Lassaigne filtrate. Now, to test for sulfur, to the Lassaigne filtrate, you add sodium nitroprusside. To the Lassaigne filtrate, we add sodium nitroprusside. A purple coloration indicates the presence of sulfur. Now, to test for nitrogen, to the Lassaigne filtrate, you add ferric chloride. A Prussian blue coloration indicates the presence of nitrogen. Now, to test for halogen, you first of all acidify it with HNO3 to liberate nitrogen and sulfur if present. Then next, you add few drops of silver nitrate. A white precipitate which is soluble in ammonium hydroxide indicates the presence of chlorine. A pale yellow precipitate which is partially soluble in ammonium hydroxide indicates the presence of bromine, while a yellow precipitate which is insoluble in ammonium hydroxide indicates the presence of iodine. So let's meet in the next video to see how we can test for functional group. Thank you. Now, let's look at how to test for functional groups. Now, to test for functional groups, we have the acidic functional group, we have the basic functional group, and we have the neutral functional groups. Now, the acidic functional groups we are going to be looking at is the phenol and carboxylic acid. The basic functional group we are going to look at is amine, and the neutral functional group we are going to look at is aldehyde, ketones, alcohol, esters, ethers, and anhydride. But specifically, we will be looking at aldehyde and ketones. Now, the first thing to do is take the unknown sample and put it in HCl, which is hydrochloric acid. If it dissolves, that means it's a base. And if it's a base, then it's definitely amine. But if it does not dissolve, then you take it and put it in what? Sodium hydroxide. If you put it in sodium hydroxide, if it dissolves, then it's an acid. And if it's an acid, that means it could be either phenol or carboxylic acid. Now, if it does not dissolve in both of them, then that means the substance is neutral. The substance is neutral. Therefore, it could be either aldehyde or ketone or anhydride, esters or ethers. But we are going to limit ourselves to aldehyde and ketones. Now, the next thing is to test between the phenol and carboxylic acid. If the compound is acidic, that means it's soluble in sodium hydroxide. That means the substance is acidic, which makes it either phenol or carboxylic acid. Now, what do? We add NaHCO3, that means sodium hydrogen carbonate. If there is effervescence of gas, then it is carboxylic acid. If there is no effervescence of gas, then it is phenol. Now, if the substance is insoluble in the two solution, that means in the base and in the acid, in HCl and HNO3 or H2SO4 instead of HCl, any of them you use is okay. So now, if it's insoluble in the acid and it's insoluble in the base, that means the compound is neutral. Since if the compound is neutral, then we subject it to what we call 2,4-dinitrophenylhydrazine test. So we add 2,4-dinitrophenylhydrazine to test whether aldehyde is ketone and ketone are present. So if it gives a positive test, that is formation of 2,4-dinitrophenylhydrazone, then that means aldehyde and ketones are present. So if they are present, then we can go further to distinguish whether it's an aldehyde or a ketone by either using Skiff's reagent, Tollens reagent, or Benedict solution. Any of these three you use is okay. So if you subject it to Skiff test, if it gives a positive test, that means change in color, then it's an aldehyde. If it does not give change, if there is no change in color, that means it's ketone. The same thing, Tollens reagent. Tollens reagent gives silver mirror color, so it's called silver mirror test. If aldehyde is present, it will give you silver mirror color, which means positive test. That means the aldehyde is present. But if it gives a negative test, that means no change in color, then it is ketone. The same thing as Benedict solution. If you add Benedict solution, if there is change in color, then it's an aldehyde. No change in color, then it's what? Ketone. So this is how you distinguish between acidic functional groups, basic functional groups, and neutral functional groups. So at this point, I wish you all best of luck. Assalamu alaikum. Once again, my name is Muhammad Abubakar Baba, popularly called Sam Muhammad. Thank you.